Well, welcome everybody. We're thrilled that you have joined us today. This is going to be a fun day full of lots of really great information in terms of what you can do with Neo4j. We'll give you a good overview of what's happening inside both the database, the graph platform. We'll explain all the buzzwords, those kind of things. I just want us to start off real quick. So I've been with Neo4j for about 2 years. I've been in the software industry marketing space for 30 now. And one of you guys will all appreciate this, my commute is awful. I live in San Rafael and Neo4j, which is across the Golden Gate Bridge, and Neo4j is in San Mateo, which is a whole other bridge, through San Francisco and a whole other bridge down the peninsula. It's about an hour 10 drive on a good day, and it could be as much as 90 minutes going home on a Friday kind of thing. So my wife got me into listening to audiobooks. And I've listened to now, I don't know, I'm pushing about 106 audiobooks since I've worked at Neo. I'm cooking through them at least 1.5 or so a week right now. And many of them, and maybe I'm just seeking them out, but many of them are really graphy, right, to begin with. And their storylines talk about how things are interconnected. They talk about where good ideas come from and the ideas around the notion of adjacent possibilities. An example of that is, all of you are right at this moment, strangers to each other. However, as you get to know each other today, there may be a couple of conversations that trigger some kind of brilliant idea in your head. That's an adjacent possibility. That's actually making a relationship or discovering a relationship in real time. And so that's Stephen Johnson's book. Because I'm in DC, because David Metz is here and going to talk about his implementation, I've got lots of space references. If you happen to see, I was here last year as well. I have a background in the space industry. My father built spacesuits, right? So he would come down here, he would go to Houston, he would go to Kennedy Space Center. So I've got kind of this long-standing thing, bit with NASA. And now what's actually gets even more interesting is my 25-year-old daughter now works for a space observatory in Oakland, the Chabot Science Center. So I've got this thread, a connection, if you will, of space kind of activities going on in my family. So one of my favorites here is The Right Kind of Crazy. That's the JPL story of getting to Mars. Rocket Men is a great story of getting out and around the moon in a condensed window of time over Christmas. Beat the competition into space and set everything up for Apollo 11 landing on the moon. There's a number of other great ones, like one of my favorites is this Burglar's Guide to the City. It looks at how and explains how bad guys traverse through different areas and look for reasons and ways in which to get in and out of buildings. Right? They basically, when they're, I'm a big fan of heist movies, so I like the planning exercise of setting up one of these heists. How are we going to get out of the Met? How are we going to get out of, if I just pick on Ocean's 11 for a minute, how am I going to get out of Las Vegas, right? With the loot. Burglar's Guide to the City talks exactly about that, and it's a whole lot of the way burglars look at the world is. Not the door, the wall. I can go through that, right, and get into other areas. A really interesting book there. Another favorite was that Disrupted book from Dan Lyons. He writes for Silicon Valley, the TV show. It was about life at HubSpot, which is a millennial-driven startup, and he's about my age. So I got a kick out of that one. End of Average is a really interesting one, especially as we start to talk about graphs in AI, which we'll get to as part of the session. Alicia's going to talk about that today. But the End of Average explains the jaggedness principle and how human beings, every single human being is unique, right? There's no such thing as an average person. right? There's specific attributes that make all of us special. And I've kind of latched onto that as some of the reasons why graphs in setting context for what you're going to embark upon, whether it's analysis or building a transactional application, kind of remembering that if your AI-based system is designed to be figuring out what the behaviors of people are going to be, remember this thing of the jaggedness principle. You can get to the right recommendation or the right offer or the right decision through multiple paths because everybody's so unique. Another favorite, and before I jump onto this one, is that revenge of analog. My graph looks kind of like this. It went too fast. My graph is is built up of here's me. I have 2 kids, both daughters. One is very, very sciencey, as I just mentioned. The other one is very performance-oriented. She's studying theater. Of course, I work at Neo4j. I'm married. My personal thing that I like to do is I like live music. So I picked up my Chuck Berry icon. I really like that one there. I do consume a lot of media, like probably all of us. I'm slightly disappointed with the season 8 of Game of Thrones right now. But there's a funny one about Game of Thrones that I've used as part of my intros here in the past. That's a very, very graphy TV show. It's all about the characters, their relationships with each other, the families, their locations, things like that. Those are all very graphy concepts. And of course, Game of Thrones, the whole series is basically a series of road trips, right? Everybody schlepping from one place to the next, right? And through Westeros, Essos, et cetera. Of course, I live in California. I've got other, my commuting vehicle kind of thing, getting me around town or getting me up and down the Bay Area Peninsula. Part of that, one of the things that I was realizing as I'm listening to those books and I'm building my graph out here was, again, how graphs themselves, I'll keep talking about this idea of what makes graphs so special that I'm starting to realize is they are a very, very natural way to understand the world around you. And the world around you it breaks down into really easy to understand and fundamental kind of components. It's got people in it, right? It's got things that we do. There are processes or activities or events that we attend. It's got devices that we use to perform these things on. Oftentimes those devices are networked, right? So this idea of, we have, and amongst the people we have social networks. Amongst the networks we have telephony, we have internet, we have your streets out there, the network of freeways that we've got or highways that we've got. So all of those ideas of how we're living our lives, how we operate in the world, is actually a very graphy set of entities. And we'll keep talking about that as we move forward. I want to highlight some of my favorite things about, and one of the reasons why I really like coming to Washington, D.C. and talking about what we're doing in the world of graphs. Because, of course, this is a hotbed of graph activity. We have, I'll talk a little bit about ICIJ a little bit more as kind of giving you what the heck is he talking about when he talks about graphs? I'll use ICIJ as my example. That's the International Consortium of Investigative Journalists, right? The news people who are making news all over the place. These are the Panama Papers people. We have David coming up to talk about how NASA's using Neo4j in its planning exercises, building out a big knowledge graph there. And then, of course, we're in life sciences as well. We've got a number of projects that are designed to identify and help cure cancer. We've got projects that revolve around diagnosing and understanding the behaviors of diabetes. So some really, really great kinds of use cases under this banner of we're helping organizations, helping the world itself understand and make sense of the information that they're dealing in. There's another great one that's a great example here in the DC area is In-Q-Tel. Is anybody from In-Q-Tel here? Was that a yes?
I've heard of it.
Okay. So they're a customer of ours, right? And they've spoken at Graph Connect events. And what they are, they're a venture capital firm. And what they do is they evaluate technology, all kinds of technology, whether it's software, hardware, biologics, robotics, all kinds of different technologies. But as they do that, the problem they realized was, if I want to create an answer to a mission that the intelligence services are requesting of me, that's their customer, intelligence services, they define these interesting problems that In-Q-Tel is geared towards figuring out. So what they had to first understand was, I need a common catalog of how to sort the different technology parts. So if I want to create a robotic drone that drops in a 5G network wherever I want it to be, perhaps in the disaster recovery kinds of activities, like after a hurricane hits or those kind of things, drop in that an instantaneous 5G or 4G network. That's a lot of different technologic components. So what In-Q-Tel has done is they decompose these technologies into different parts and then reassemble them into a solution that might, and redesign them into a solution that might solve the missions that the intelligence agencies are requesting. So the way to look at this graph there is, the blue dots are the major intelligence agencies in the US. The green dots are all of the technology suppliers that might have an answer to what they're looking for. And then the connections in the middle are where each one of these suppliers has a technologic component that would solve some of the mission instructions for that In-Q-Tel is investing in. So as they built both that visualization and the toolkit around it, right? As I mentioned before, they're also a VC firm. So they've got capital that they're going and reinvesting in these companies like Palantir, et cetera, and using that as the vehicle to keep themselves in business. Otherwise, they're a nonprofit, right? They're really just the technologic designers here. Just to kind of set everybody's, tell the quintessential Neo4j story of the Panama Papers. Right, you guys all remember this, right? This was a Snowden-style leak of data from a Panamanian law firm called Mossack Fonseca. They specialize in tax shelters. So 2.5 terabytes of a hard drive left the firm. It had 11 million plus documents on it. And the documents themselves had specific pieces of information within it, like who's the account holder that, is there an individual that I'm trying to understand what's going on? And each individual has, moving to the left, an account held at a bank. And they also have their own home address, right, is moving to the right there. And at the home address, there's a spouse or a significant other that also lives at that address. Now, what's interesting that ICIJ uncovered was, that spouse is an officer of a shell corporation who also holds a bank account somewhere in the Caribbean. So that was basically the mapping of what they were looking for. If we turn this into a graph, we have things like a US bank, an account, person A, the address that they live at, person B, where we're connecting the relationship, and then their shell corporation and where their bank happens to be. This is a Bahamian bank in this example. Well, these are nodes. Relationships are connecting them. Relationships are directional. They have a label that explains what they do. And hanging off of each one of these can be properties. Right? Properties are just key value pairs of information that enrich or set context for nodes and relationships. We'll talk a little bit more about that in a sec. This is what the big graph of Panama Papers looks like when you zoom out and take a look at it. And as you can see, the big cluster there is the group of accounts and people and transaction holders around that law firm Mossack Fonseca, and then starts to get into where's all that money going. So of course the outcome of Panama Papers originally was it brought down the Prime Minister of Iceland. It also took out the Pakistani Prime Minister as well. It was featured in hundreds of articles worldwide, hundreds of articles, talking about what's going on in where all of these high-profile individuals are hiding their taxable income. They won the Pulitzer Prize out of this. So that was a pretty big deal, right? As investigative journalists, this ICIJ itself gets the biggest journalism prize back in 2017. And this is what their core data model looks like. It's really simple. As I mentioned earlier, graphs are really great at creating an environment where you can model in a very simple way the structure of your data or the interrelationships of your data. Well, guess what happened to the ICIJ? They did it again, right? The Paradise Papers, right? Different law firm, Appleby this time, same kind of leak. And instead of being about individuals and where they're hiding their money, this is about corporations and where companies are hiding their money. So the corporations in question were Nike and Apple. Right, we all kind of know the story of Apple, right? A lot of their income is held offshore and is developed internationally. They had their international headquarters in Dublin for a long time until the EU decided to crack down on and collect their tax revenues out of Ireland. So you know what Apple did? Guess where they moved? To the Isle of Jersey, in the middle of the English Channel. It's got about 70 people in it, 70 residents. Very, very, very favorable, business-friendly tax laws. So that's where Apple's new corporate, European or international headquarters is. So as I said, ICIJ went through and figured out all of these other additional relationships and peculiar practices of lots of these different organizations. And again, they were recognized and rewarded for this work. This time, most recently, by the Golden Globes people, the Hollywood Foreign Press Association. They made a grant of $1 million to keep the ICIJ working moving forward. And I'm certain, anyone from ICIJ here? Because some of our folks are local here in DC, MAR, et cetera. No? Anyway, I don't know when all these things pop out as news items, but I'm fairly certain they will pop out as news items coming soon. We've got another one is the Russian troll attack. We've actually mapped out based on Twitter information. We work with Ben Popkin. David, did you work on this one? I'm looking for that guy over there worked on this one with Ben. Dave's a local resident. He lives in Richmond, and ended up mapping. Here's all the activity and forwarding activity of these particular Twitter troll. The Twitter troll was the originating node, and then where did it spread and how did it go across Twitter is mapped out here on this particular diagram. And lastly, Preston, are you here? There we go. Preston's going to come up and talk about his work on U.S. Army. This is another great use case. I'm not going to spoil it for him. So as you can see, there's lots of great use cases here in the DC area using Neo4j in lots of different means. So next what I want to talk about real quick is give you just the rundown of where we're at, what's happening in the graph market right now, and where we see Neo4j, our product lines going. And while I'm going through this, I'll keep highlighting some of the other, as we talk about some of the innovations, I'll highlight perhaps some of the talks that are coming up this afternoon so you get a flavor of how we're expanding this series of discussion. We're still a startup, but we're a very mature startup at the moment. We're growing very, very rapidly. We took on an E-Series round of funding back in October, and I think all of the employees here of Neo4j are feeling very confident in our ability to grow and really define the graph market. It's been a goal of mine is to make the world of databases recognize that graphs are really special and very, very different from certainly SQL-based systems, but even more importantly, different from NoSQL types of databases, document databases, key value databases, columnar databases. We're not anything like that. Right? Graphs are indeed really unique and special in their own way because they talk about and reveal relationships in among data rather than how to actually store it efficiently and aggregate it and tabulate it. So we're seeing kind of this rise of connected data happening in the market. And as I mentioned earlier, all of these different types of data types that are happening, you can look at and recognize the graphy nature of this, the relationship-oriented nature. There's graphs of and networks of people, right? Those could be employees in an organizational hierarchy. They could be customers, right? Your favorite, or prospects in a customer 360 kind of application. They could be other influencers, partners, et cetera. There's business processes going on. Everything that we're working on, whenever you get organized and decide that we're going to map something out and change the way we work, that's a process exercise that every time you draw it on the whiteboard, you're actually building a graph as you're going through this exercise. There's knowledge networks, right? Of what's the relationship that I have to all of that stored up information that I've developed historically. That's not satisfied by simply looking at how what my accounting for all this stuff is. It's things like the content management systems we have, the maintenance orders and maintenance records that we're carrying on, perhaps equipment that we support. Those types of there's activities that we performed in the past that we'll talk about. These knowledge networks or knowledge graphs are what inform the next generation of applications that you might be building. And we'll talk about that in a second. So I want to plant in your head, right, if you have this institutional knowledge and you're not revealing how all of that is interrelated amongst itself, and what that can help do to help you drive better applications, more intelligent applications above it, hopefully by the end of this, not only this session, but this day, you'll recognize that these things fit together really, really nicely as, given the kinds of systems you want to build out in the future. Very quickly under the what's a graph, why do you keep saying it's simple? Well, because it's basically this kind of structure. We have nodes, those are the big circles. They're kind of like when you write a sentence, these would be the nouns in your sentence. Relationships would be the verbs in your sentence, and they talk about how these nodes are interrelated. And as you can see, you can have multiple relationships going to the same node or going to different nodes. Relationships in the property graph are directional, but when you query them, you can traverse them in either direction. Because a node always knows where its next node is or who it's connected to. And that's one of the cool things about the graph database that makes it really special, is the way in which, all the way down to the storage level, we end up defining, we call it index-free adjacency as the feature name, but it's the way that we store a node and then right around it we store all the pointers to the other nodes that it's related to, both inbound and outbound. So it's very easy for us to look at that node and then just jump the pointer to where its relatives are. And imagine doing that 20 hops at a time. As I mentioned before, both nodes and relationships can have properties. These are basically attributes and other, if it's a relationship, maybe it's a weighting. How important is this particular relationship among these two nodes kind of thing. And then some of the properties could just be additional data, like, where's the Volvo parked, right? So I've got latitude and longitude support built into the property list. That car happens to be parked in San Mateo, California. So as I mentioned earlier, graphs themselves are really different from your SQL perspective, although SQL is a precursor to building out graphs. When you've got tables and you're joining them with foreign keys, right? That's actually, when you query that and you do a join, that's actually a materialization of the sets of relationships of how the records in one table are related to another set of records in a different table. So that's kind of cool, right? You materialize those set of relationships when you run the query, but guess what? You don't do anything with them after that. The difference with graph is it keeps those relationships around. From a functional standpoint, I think we'll end up getting, Anurag will talk quite a bit later on this afternoon about the real core technology inside of Neo4j. I've mentioned index-free adjacency. We're a good database on the ACID side, and what we're seeing in the space is because we deal in relationships, And relationships themselves are so important. They're primitives in our product. And the core thing that you have to have when you're writing a graph database is one node needs to know where it's connected to the other node, and you have to write the relationship. So you're actually writing three different things. The node, who it's related to, the relationship itself, and then where the recipient is. It's hard to break. You shouldn't break those. So being an ACID database is a really, really important concept in the graph. Right? Relationships are really precious in that regard. We do have fault-tolerant and high-availability clustering for writes. We have infinite scalability for reads. So if your application is looking at that knowledge graph and absorbing your information very readily, that works really well there. We've got all kinds of, who's an application developer in here? Very good. And who's a data scientist or working on the analytics side more so? Nice. I like this balance of kind of half and half. So for the application developers, got all kinds of drivers that make embedding and using the database itself, and fitting in your particular development stack. For the database analysts, we've got graph algorithms and lots of means to teach you about how to take advantage of graph itself in much more of like a data discovery way if you want to operate akin to Tableau, or in data science, how to apply specific graph algorithms to solve your problems. Of course, we do have both open source and commercial products. This is my kind of quick summary of what's the difference among them. And really the key is, the open source is for the developer characters who really want to see what's happening inside the graph and dive into the technology itself. We publish the code, we make that freely available to you. Great learning tool, great way to understand the product itself. The Enterprise Edition is for really your production-oriented environments, especially if you're going to serve customers, especially if you need high availability, or if you're one of these enterprises who cares about security, right? And you want to govern access to the system, who's got access to different parts of the graph. That's all in the Enterprise Edition of the platform. We characterize it as a platform itself, supporting both those transactional types of applications on the development side, and on the data science side, the analytic types of applications. And projects. And then we do have Neo4j Bloom we'll show you later on this afternoon. We can talk about all kinds of ways that we get data into the graph. A keyword there is tables for labels, right? Your table structures are going to indicate what the nodes are going to end up being, what you might call them as their node type, and then how you might assign properties to them themselves. We're on version 3.5 of Neo4j right now, and working feverishly to get to Neo4j 4.0. You'll start to see us talk about that coming up in the summertime. I will allude to what's coming up in 4.0 in a second. But 3.5 has some really very, very fun features like full text search finally. Native indexing across throughout the database itself. So no longer are you, that makes querying the system really, really fast. We keep rewriting the query and the query execution engine to make it faster and faster and faster. We've done this successively through the last 5 or 6 releases that I've seen, and the execution speed of Cypher, our query language, has gone up probably has increased in its performance tenfold. For you folks who are going to get your hands wet directly in the system itself, we have graph application. We have the Neo4j desktop, which supplies you a copy of Enterprise Edition, free for developers, and gives you a foundation for investigating and understanding all of these other applications that go along with it. These might include the algorithm library, some other tooling in here. This is what Neo4j Bloom looks like. And as I said, I'm not going to steal Anurag's thunder here. This is a graph discovery and visualization tool that we've brought out. Helps the rest of your teams understand what's going on inside the database. And as I mentioned, 4.0 coming up has some great new features, including multi-database support inside an instance of Neo4j. So just like Oracle, MySQL, Postgres all support multiple databases, right? That's number one. Neo4j Fabric is a code word for probably one of the most requested features of the graph environment ever. We'll start to talk about that. And then even more, we'll call it schema-based security mechanisms, because if I have to do something like make a fabric of lots of the graph and make pieces of the graph all over the place, get it? Pieces of the graph? That's a really hard problem to solve. It's taken us about 10 years, but we're on the path right now. So if I have to allocate it out like that, I have to have really good security about where I'm routing all the requests. So if I have to write to this side of the graph over on these machines, I want to secure that in a way so that and secure and route it correctly to the right location in your very, very large graph. So addressing those particular needs of Neo4j is only a single instance graph database. Yes, that's true right now. There are certainly reasons for it, like that that ACID support. But coming up soon, we'll show you how to break apart the graph and make subgraphs out of it. Of course, graphs are really hungry for data. We do a great job of mapping ourselves across different data sources in this kind of environment. The popularity is surging right now. We use DB Engines, which is a database tracking environment that declares what's happening in the database space. Well, on May 1st, at the turn of the month now, since we started tracking this ourselves, there's the big green line is the graph line. And this is a popularity contest. It's a popularity score. It's how much of this requests about graph systems is happening on the internet, in LinkedIn, in job posts, in tweets, et cetera. And you can see that we're growing, continue to grow like crazy. We just crossed over the 1,000% growth rate, right? That's what the top threshold line is that we just crossed over. As Dave said, you folks here are a member of more than 2,000 participants in the GraphTour conferences that we've been holding, and this is we're bringing this city to you. But we're enjoying more than 20 million downloads of the product so far. That number's probably even obsolete already. We do hold, both online and in person like this, more than 400 meetups and events worldwide. So there's pretty much every day there's some kind of Neo4j event happening. Euler's birthday was a big one. He's the kind of the father of graph theory. We celebrated that. It happened, I think it was April 15th. So a big internet event there. How many people here are certified Neo4j developers? Are you among the 50,000 there? That's great to see. And then, of course, meetup groups. We have a thriving developer community. We've got a great team of about 7 or 8 developer relations folks who are really, really focused on just making sure developers are getting what they need out of the open source. Of course, back to that Panama Papers graph. As you can see, if I've got the graph on the left-hand side, the 5 hops, there's value in that. But the bigger value is in the big dense graph on the right-hand side. So the more densely and interconnected the information is, the more valuable it becomes. I also mentioned earlier that we're trying to push the industry itself, the analysts, the folks who are evaluating what's happening in the market, into recognizing that graphs are special and unique in their own way and therefore deserve their own market category. And this belief is starting to loosen, right? They're starting to buy into this. As you can see, the clever quotes like from Frost and Sullivan is, it looks like data connectedness is indeed a different paradigm. From the financial analyst William Blair said pretty much the same thing. So the momentum continues to build for graphs and for us in general. And as I say that, right, one of the reasons why I'm highlighting it is because this graph notion, the ability to think about the graph, draw it out on the whiteboard, code it up in Cypher, execute your applications and your queries, in your system, and get it all the way down to storage, the bytes and bits on the drive. All of that is graphy. All of that is consistent inside of Neo4j. Other systems out there, even the graphy ones, the Amazon Neptunes, the other folks that are here in the building, have a graph-based product. All of those guys are doing funny transpositions at the compute and storage level. It makes their products much slower, and not native in their graph approaches. And then, of course, SQL, while has that same kind of nativity for RDBMSs, right? Really, as I talked about earlier, doesn't persist and maintain the relationship information. It manifests it, only when you're executing the query. Very, very happy. I'm gonna wind down right now. Very, very happy to discuss, who else is out there in the market, how do we see them, that kind of thing. But really, what I want to end up getting to is, our common sets of use cases here. Who's using them? So use cases like real-time recommendations, like fraud detection, IT operations, master data management. You can see how graphy all of these things are. They really, really are. And then you can see, kind of my list of core customers who are doing this kind of activity. I'm going to leave you real quick on a couple of more use cases, and then we'll wind down. First one is helping figure out, how diabetes behaves. And we've got the German Center for Diabetes Research is our folks who are building this out. And they're building out a vast knowledge graph that is, see, look, there's my timer. Vast knowledge graph to help resolve that particular problem. We've got more than 300 organizations using the commercial version of Neo4j. There's tens of thousands of graph projects out there, right? So you're in good company here. And then finally, another interesting use case that we like to highlight is users, what their particular jobs are, what they do. They're artists. They make designs. Software companies like Adobe, right, support this kind of behavior. Adobe Behance is a customer of ours. They built a social network for their customers of graphic artists. There's 10 million of them out there. And this social network Behance is like the job listing environment and the creative display, an online museum kind of thing of all the different graphic artwork that's going on in the world. When they built this system, the challenge to building this system, like any social network, is how do you support high-speed feed information to each user, especially when you're dealing in documents and pictures of everybody's artwork. So the feed that they built originally, they deployed the system in MongoDB. They had 150 instances of MongoDB operating this thing, and it was way too slow. You couldn't see who did something new. Your activity feed would fill in slowly. It wouldn't update when you actually chose to follow a new artist and see what they were doing. So they got really sick of that particular deployment. So instead of going document, because artwork is kind of document-based, they went columnar with Cassandra. And they shrunk their footprint, their IT footprint, by 1/3, which they felt really good about, except it didn't solve the problem. The activity feed was still really, really slow, not performant. So then they went to Neo4j. And so 3rd time's a charm, right? Realize they redeployed this thing 3 times. They got it down to 3 Neo4j servers. Performance is going great for them. And by building this in the graph itself, right, they're able to isolate exactly what the important information in the graph is, link to artwork and things like that as it comes in. But we shrunk their data footprint from 50 terabytes in that Cassandra system down to 40 gigabytes in the graph. So the graph itself, when you get your head around exactly how to build these things, is and get the performance that you're looking for, you don't have to put everything in the graph, right? You only have to put the important things in the graph.